two trans alkene. Okay. All right. So example, I did this. Review this one. And then the reactant is Na, sodium in ammonia, liquid ammonia. It gives you trans alkene. Okay? I did this in class, but review this. Okay? It's also in the PowerPoint. Okay? And the first step is to make sodium becomes Na plus 1 electron. And then it's gonna add on the double bond, on the triple bond, all right? And then you need 2 of these, Na forming Na plus, and then this carbon absorbs the electron. Okay? Got that? Okay. Now I'm gonna go over the rearrangement because you were asking this, all right? So 3 mechanism question, right? So can I erase this? Good. Okay. So you were asking about hydride shift, correct? And then ring expansion. So there are 3 things. So for example, the one I did in class was this. Okay? Okay? So when I gave you the handout, I gave you this. Okay? So it's like this, right? So I gave a lot of space. So that means you have to write a lot. And then short space, you don't have to write a lot. Okay? So I think this is the one that okay? So this one can undergo, so the first part, actually, the second part is I had this one, POCl3, okay? And I said 1 product, only 1 product, okay? Right? These questions are big pointers, so study this.
E1, is that E1?
So this one, I asked for the mechanism. What is the mechanism in here?
E2, because there's only 1 product.
Yeah, it's bad.
Okay? Only 1 product. And you know, this is an alcohol to a alkene. Only 1 product, right? So when you do this, you can write first the products, and then you can go backwards to do the mechanism. Okay? So 1 product, and then the other question is, I have this. I did this in class, right? And then I said multiple products, H2SO4. All right? So this one can undergo 2 things, alkyl shift and ring expansion, but not hydride shift. So review this, okay? All right. Now, what would be an example in which you have a hydride shift? So you see this one, right? So this can ring expand to 6 carbons. So the one that I did is just 5 to 6, all right? And I did not do 6 to 7, all right? I did not do 4 to 5. Typically, 4 to 5 is okay because 5 is a good size of a ring, or 5 to 6, but I'm only giving 5 to 6, okay? So the number of carbons here actually is 8. 5, 6, 7, 8, okay? So if I have a molecule like this, okay, I don't have the stick here. Okay? So this one can undergo
Hydride shift.
hydride shift, not ring expansion. Don't try to expand, will not. Okay? So it can only do the same thing as the other one because you have this. Alright? So I can change this. So for example, I can do this too. Right? So I wanted to understand what will undergo a hydride shift. Because the neighbor doesn't have another carbon. Okay? It's just a hydrogen. And then it's gonna go here, the plus, because it wants to be stable because all of these are secondary structure. Secondary, okay? It becomes a tertiary one. Okay, so those are the structures that you're looking for. So for example, I now have this molecule. So if I combine this, right? Okay. What if I have this? The same thing as that one, right? So this one will undergo what? So the yeah. Okay, so this is the intermediate structure, secondary. Okay? So without undergoing rearrangement, the product would be don't make a double bond in here because that's 5. Okay, you're gonna have a double bond in here. Okay? So, but because you have this, then this one can undergo alkyl shift, ring expansion, this one only hydride shift. Hydride shift. Okay? This one can undergo ring expansion and then alkyl shift. So you're gonna have products. So basically, write first the products and then go backwards because I'm just looking for intermediate.
So how many products would that bottom one have?
So you have to work it out.
Okay.
I would say, if I say more than 4, that's gonna be more than 4. So at least write 4.
Right.
Okay? It's the same as the one that I was doing. Okay? So those are the, yeah.
The first one up there, tippity top. That,
This one?
yeah, that one,
Okay.
the one that forms one product, yeah.
Yeah. So all products are alkenes.
Yep.
Okay? So how about this one?
That one takes the O's out, and then,
Okay.
oh, it's at
So-
the end.
So write first the product if you want. So it's gonna be like this. So,
Yeah.
okay?
That doesn't undergo any shift.
Nothing.
Cool.
But you can have an intermediate, but the plus is not on the carbon. You will not have a carbocation.
Yes, cause.
Okay? So again, when you do the mechanism, this has to be pulled out. The same thing as SOCl2, the same, similar, right? So if you do that, it's gonna look like this. So the technique is to expand the structure of the reactant. Expand it. Okay? Phosphorus, 5 bonds. 5 bonds on the phosphorus. So at some point you have to make this connect because this has to come out. Okay? So just make bonds, right? From the P to the O. So again, you're gonna take out a Cl. All right, so Cl minus, and then plus, and then phosphorus O, Cl. Okay? So now, don't make a carbocation because this will not undergo rearrangement. So only one product, and this is going to be what mechanism?
E2.
E2. So the P2, PE. I'm trying to think about how to
P1 product.
Well, then that's
how to remember this E2 mechanism.
P is
This
number
one is gonna be E1.
Yeah.
If I say multiple products, it's E1 because it's slower. Like SN1, E1 is slower. You're gonna have multiple products. SN2, E2 is fast, only one. Okay. So basically, only like 2 steps. You make the bond and then take this out, and then you get this. Okay? So what you form is, you follow the arrow, right? PO, Cl, Cl, and then OH. And actually, this one is pyridine, but if not, you can just say pyridine,
It's pure. Oh, to take up the H.
take out the H, it becomes actually HCl.
Yeah.
You can just do that if you want, pyridine, HCl, because the pyridine is a base that absorbs the hydrochloric acid. Okay?